Alright, I want to talk about section 10.4, surface area of rectangular prisms. So we're going to look at how to calculate it really easily. First, let's build a rectangular prism that we can look at here. Man, I'm terrible at drawing rectangular prisms. And we're finding the surface area this time, so I just want to know kind of the area on each side, like this, and I'm going to add them all up. But I need to get all of the sides as well as not just the ones that I can see. And the easiest way for me to do this is to kind of tear it apart and turn it into a net, kind of like I had before. So let's take this and let's turn it into a net. And this is the net that I'm going to build from my rectangular prism. Now, of course, it's not perfect, but you can see that if I were to fold it up into a box, I would have all the pieces necessary, and it might not fit perfectly, but I pretend in this case that I could. Now, this case, the measurements of this rectangle, or this rectangular prism, we have it 5 inches wide, 3 inches long, and 8 inches. What's the other word that we're going to use? 8 inches high. Now, the thing to remember with these dimensions is it doesn't really matter what we call what in this case, because we can just flip this shape around, and it doesn't really matter especially. So, in this case, let's label particular sides different things. So, this one right here, we'll call this our 5 inches. And if you think about it, that means that this side here would also be 5 inches, because these two rectangles would be the top and the bottom, and they would be congruent in this case. And you could even argue that this would also be 5 inches, and this here would be 5 inches. In this case, we'll put our long side here, 8 inches, and that means this would also be 8 inches. This side is also 8 inches. Same with this side and this side. And you can see that a lot of our sizes are going to be coming into here. And our last measurement that we're going to use is 3 inches. And that means this here is 3 inches, 3 inches, 3 inches, 3 inches, 3 inches, and 3 inches. And in order to find the surface area, what I'm really doing is I'm finding the area of 1, 2, 3, 4, 5, 6 different rectangles, and I'm going to add them up together. So 1, 2, 3, 4, 5, and 6. So let me grab my calculator because we're going to do some math. So I'll put it here. So this, actually, I'm going to put it here so I can write. This top side, so the area of a rectangle, of course, is length times width. So I'm just going to be finding the length times the width of each of these rectangles in order to get the area. So in this case, I have 8 times 5, which is 40. In this case, I have 3 times 8, which is 24. In this case here, I have 3 inches here, and then the side here, which I need to know, which is going to be 5 inches as well, because these two sides would connect. Same with this. If I were to fold it up, and if I fold it up, it must be the same. 5 times 3 is 15. Here I have 8 times 5 again, which is going to be 40. Here I have 3 times 8, which is 24 again. And here I have 5 times 3, which is 15. Now what I'm going to do is I'm just going to add up all of the areas that I found. So I have 40 plus 24 plus 15 plus 40 plus 24 plus 15. Now, you'll probably notice, I guess I didn't need my calculator, huh? You'll probably notice here that there's a big pattern going on, that we have kind of matching pairs of sides. And that kind of makes sense because these two sides of these rectangles are going to be opposite so that they are congruent on the other side. Same with these two, and same with these two. And this would take a really long time, this section, if you had to draw it out every time and kind of match up sides and do all the math. But instead, I'd like to make a formula that I can use to kind of represent all the different sides and shapes that I have going on. What really is going on is that I have two sections of each possible dimension on the side. For example, I have two triangles that are width times length, 5 times 3, here and here. I have two triangles that are, or two rectangles that are length times height, 3 times 8, which is here and here. And then I have two rectangles that are width times height, 8 times 5, which is here and here. So if I was going to write this out as a formula, I could say that the area of a rectangular prism, and I'm going to use subscripts here to put little letters below my number. I could say that first it's width times length. Then I add my second one plus width times length. Then I'm going to add my length times height plus length times height. Plus my second one that's length times height plus length times height. Then my third one, which is width times height plus width times height plus width times height. And in this case, I can see that I have all possible sides being multiplied by each other. So in this case, I hope that kind of makes sense. What I can do then with my formula is I can even simplify it down. Because width times length plus width times length is actually 2 width times length plus 2 length times height plus 2 width times height. And this is going to be the formula that I'm going to use in order to find the surface area of any possible rectangular prism. Now remember, this only works, we'll call this surface area of our rectangular prism. And in this case, in order to do this, all I would need to do is substitute in for my answer. And let's check and see if it does work. My total would be 40 plus 24 plus 15 plus 40 plus 24 plus 15. And that's going to be 158, provided I didn't make any errors. That sounds about right. Let's try it with our formula and see how it works. Okay, in this case, I'm going to substitute in what I know. 2 times width times length plus 2 times length times height plus 2 times width times height. 5 times 8. Okay, let's simplify that down. I've got 15 times 2, which is 30. I have 24 times 2, which is 48. And I have 40 times 2, which is 80. Let's add those up for 30 plus 48 plus 80. And this equals 158. Good thing, and that does match our long-handed way of going about it as well. But this is the formula that I would use here because it significantly saves you a lot of time when you are getting the surface area of these rectangular prisms. I hope that makes sense, and go ahead and good luck.